Hi, what's going on, geometry students? Mr. Martin here to help walk you through standard S.5 area and perimeter in the coordinate plane, part one. So let's take a look at what we're doing in standard S.5 within IXL. What is the perimeter of square WXYZ? So here's WXYZ right here, and they're just asking us for the perimeter. Well, take a look. This one's pretty simple because we have horizontal and vertical lines comprising the sides of this quadrilateral. Just count it out. Each square, always check that. Each square is 1 unit apiece, even though they only numbered every other square within the coordinate plane. But we've got 1, 2, 3. So that length of that side's 3. 1, 2, 3. We've got 1, 2, 3. And 1, 2, 3. So the length of each side is 3 units. Therefore, the perimeter is 3 times 4. That's 12 units. 3 times 4 is 12. So the perimeter there is 12 units. Wonderful. Fantastic. And we got another one very similar to that. Let's jump up a level. Let me get rid of that annotation off the screen there. So now we've got a triangle. What's the perimeter of triangle CDE? So perimeter of triangle CDE. Well, I would say that the length of side CD and the length of side DE will be pretty simple. We go from point C's at -10, point D's at 10. Well, that's 10 units to the x-axis and another 10 units. So we're looking at 10 plus 10. That's 20 units. Okay, we're looking for distance, so I want the absolute values. That's 20 units there from C to D. And then the length, or the distance from D to E, well, D's here at -10, so that's 10 units to the y-axis. And then it looks to me like it's 5 additional units to get from the y-axis to E. So that's 15 units. 15. Well, now I've got a right triangle here. We know it's a right triangle. I'm looking for the length from C to E. There's a lot of things you could do here. You could use Pythagorean theorem. And actually, I think that's the route I'm going to go in this instance. I can use Pythagorean theorem. I've got 15 squared plus 20 squared equals, I don't know, we'll just call this C. C squared. Okay, remember our Pythagorean theorem, a squared plus b squared equals c squared, right? So 15 squared, pull out your perfect squares here, that's 225, right? Plus 20 squared, that's 400, equals c squared. Well, that's 625 equals c squared. Well, 625 is a perfect square in and of itself, so that's really cool. Square root of 625 is 25. So C is 25. The distance from point C, so don't get that confused with side C. You probably should have picked something different, but don't worry about it. The distance from point C to point E, that's 25 units. Now, what's something else you could have hopefully seen? Well, this is just a 3, 4, 5 Pythagorean triple. 5 times 3, 5 times 4, 5 times 5. So if you saw a Pythagorean triple, that's pretty cool too. Now, I want the perimeter, so you need to add those up. That's 15 plus 20. Plus 25. Sum that together, what is that? 35 plus 25. And that's 60. The perimeter of this triangle, the distance all the way around the edges, 60 units. So let's scroll down here. We're going to type that in, 60. There we go, 60 units. Hit submit. Awesome. All right, let's get rid of those annotations. Let's see what else we have. Now this one asks for area and perimeter. So let's do this one really quickly. We just have horizontal and vertical sides, so that makes life pretty easy when it comes to finding the length of each side. Again, we're just using 1 unit for each square on this coordinate plane. So this is 2 units here. And then as we move from 10 to the x-axis, that's 10 units. And then from the x-axis to -8, that's 8 more units. So this is 18 to 18. So we've got 18 times 2 plus 2 times 2. That's my perimeter. That's 36 plus 4. So 40. That's my perimeter, okay? Area on the other hand is length times width, right? Length times width, okay? Maybe base times height, depending on how you want to think about that. But area, length times width, 2 times 18. So 2 times 18. The area is 36. And now we need to be specific here. So the perimeter is 40 units. The area is 36 units squared. So that's units squared right there. So let's scroll down really quickly. What's the area? The area is 36 square units. The perimeter is 40 units. Submit. Awesome. Awesome job. All right, so now you got a good idea of how to do a problem like that. Let's jump up another level. Let's see what we're dealing with. Oh, it automatically throws me into the challenge zone. All right, so find the area of square. So we know it's a square, BCDE, with vertices B, C, D, and E, and they give you the points there. What's the area? What's the area? Well, basically, I know it's a square, so I know that each side is congruent. Well, that means if I can find the length from, say, for instance, B to C, then I can just square that or multiply it by itself to get the area, because keep in mind, and I'm just going to draw a square here as best I can. In fact, I'm going to use this fancy tool here. Let's see if I can draw us a square. Here's a square. Okay, there's a square. If I can just find the length of one side, if I can find this length, for instance, from here to here, well, then I can just multiply that by itself to get the area, right? So hopefully that visual helps you out. Well, how do I find the length of any given side? I need to find the distance from B to C. So that means I'm going to need to use my distance formula. You may or may not remember this guy, but it's x2 minus x1 squared plus y2 minus y1 squared. So the distance, or the side length is really the distance, right? So my side length, or my distance, I'm just going to write equals here, square root, and we're going to go from B to C here. So x2, negative 4, that's negative 4, that's negative 4 minus, right? So we're not going to multiply that yet, minus negative 4. All right, well, that's going to be pretty easy. Subtraction. Negative 4 minus a negative 4, that's just 0. Of course, we're going to square it. 0 squared, still 0. And then we have 8 minus negative 6. So 8 minus negative 6 squared. So that equals the square root of 0 squared plus 8 minus a negative 6. Keep in mind, when we subtract a negative value, that's taking away the negative, or basically adding the absolute value there. So adding that number. So that's 8 plus 6, that's 14 squared. Well, 0 plus 14 squared is just 14 squared. What's the square root of 14 squared? It's just 14. So the length of any given side on this square is 14 units. What's the area? Well, the area is going to be 14 times 14. It's going to be side squared. That's the area for a square, length times width. All right, well, 14 times 14, that's one of your perfect squares that you ought to have up in your noggin. That's 196 units squared. So let's type that in right there, 196, submit. Good work, fantastic. All right, we've got one more. Let's do this one that says area and perimeter. Let's get rid of all my annotations here. I'm going to probably have to delete this guy. Let's see. There we go, delete. Find the area and perimeter of a square. Oh, it's another square. Probably should just leave my square on there. There we go. Find the area and perimeter of the square with these vertices. Well, keep in mind that a square has all sides congruent. So the perimeter, if I can just find the length of one side, I can multiply that by 4 to get my perimeter, and then, of course, square it to get my area. So we've got side. Let's try to find again the side length, which, of course, is really just my distance. And it doesn't matter. I'm going to show you it doesn't matter what points you use. Last time I used the first 2 points. I'm going to use the second 2 points this time. It doesn't matter. All right, so I'm going to use T and U. I'm going to use T and U to find my distance here. So 3 minus, what is that, negative 8 squared. Put another parentheses there, plus negative 6 minus negative 8 squared. All right, so that equals the square root. Well, 3 minus negative 8, the same thing as adding, right? Same thing as adding, so 3 plus 8, that's 11 squared, plus negative 6 minus negative 8. So negative 6 plus 8, that's 2 squared. So that equals, what is that, 121 plus 4? Well, that's the square root of 125. Which, by the way, we can simplify that. 125, that's, let's see if we can simplify that root. I'll take that over here. That's what? square root of 25 times square root of 5, right? 25 times 5 is 125, so that's 5 root 5. So the length of any side of this square is just 5 root 5. So what's the perimeter? Well, the perimeter would be 4 sides times 5 root 5. Oop, that should be root 5, not root 25. So 5 root 5. So that's 20 root 5. That's my perimeter. Okay, what's my area? Well, my area is going to be 5 root 5 times 5 root 5. And you might want to think about it this way. It's basically square root of 125 times the square root of 125. Well, that's going to be 125. And that's units squared. That's my area. And then this is just units up here, 20 root 5 units for perimeter. So let's go type that in real quick. Perimeter is going to be, let's see, 20 root 5, so square root. Let's see if we can type in square root. Oh, they don't like that, so let's pause real quick. Oh no, I just went back and checked. I made a mistake. How did you let me make that mistake? No, I'll claim responsibility for that one. This was not 8. That should have been a 6. So that's going to change a little bit of what we got going on here. I'm going to erase this. I'll make sure to notate that when I send this video out. But try to salvage this thing here. Let's get rid of that for just a second. And let's get rid of this. In fact, this problem ends up being a lot easier. So when you have -6 minus a -6, notice we got -6, -6 here. So that ends up being 0 squared. So that's 121 plus 0. Square root of 121 is 11. So S is 11. So if I want the perimeter, that's going to be 4 times 11. That's 44 equals perimeter. And that's units, by the way. And then area is just going to be 11 times 11. That's 121 units squared. That's area. All right. Apologize for that error a second ago. I think I was looking at the -8, but it should have been -6. So what's the area? 121. What's the perimeter? 44. Submit. Excellent. Fantastic. So I'm going to get rid of that. I'll make sure to notate that error later. And hopefully this gives you guys some help. Let me know, geometry students, if you need any additional help. Talk to you later.